Privilege for me to speak tonight. We are just taking a helicopter view on cloud computing. So we're doing just an introductory approach to cloud computing. We're just going to dust cloud technology. We're not doing anything serious. So I just want to try to set the stage to make us happy and understand that the concept of cloud computing, it's not fully grounded to everyone yet, because we see an IT operator whose boss have asked them to move to the cloud. He went to pack up all the servers and is waiting for the address. And the address for the cloud, we don't know where to find it. So that takes us to the main agenda for today. We'll be looking at the fundamentals of cloud computing. We'll also look at the benefits of cloud computing. We'll look at cloud computing models, the deployment models as well. There are some common use cases and public cloud providers. Without wasting much of our time, the fundamentals of cloud computing, it's basically an on-demand delivery for compute power, for database, for storage, applications, and other forms of IT resources that you want. Actually, it's a solution whereby you can pay for what you use, pay as you go, and at the same time save when you use more. We have three major types of cloud services that are available. The first one is what we call the IaaS, which is infrastructure as a service, where you have a full infrastructure in the cloud dedicated to your organization for the kind of service you intend to run. Then you have platform as a service, and as well we have software as a service. We know platforms like Uber, like Enterprise, these are platforms that we can actually use their services. Then software as a service goes for solutions like our normal applications on the phone, like your WhatsApp, your Facebook, Google, Gmail. Most of these solutions are all SaaS products, and they can be hosted in the cloud anywhere. Remember the story of Trump when Parler was suspended by AWS because of some violations. So here it is the functionality and the tax ownership, including the flexibility, that are the key drivers of making a decision of what kind of solution you'll be looking at. So I tried to put a pictorial here showing that, for instance, we're in creation technology today. Creation might have a solution where everything is on site. That talks about the first line here. Then if they decide to say, okay, we want to put some of our solutions in the cloud, then they can gradually start to move. Maybe start with having an infrastructure until they start taking their service as a software from the cloud background. I'll try and show some more light. Normally I would have asked questions at this point, but I'll just explain. The guy that has the key to his car is actually a guy that's the one when you hear people say on-premise DC. DC stands for data center, whereby you manage all your infrastructure, your networking, your everything about your IT resources is managed on premises. Then when we come into infrastructure as a service, it's where you obtain the infrastructure to run particular services. You no longer think of managing your hardware. You don't think of upgrading your server, upgrading your database or something. All you think about is, how can I make so much money and keeping my software running, because you are now responsible for the security of your software. When you talk about a platform as a service, like I mentioned earlier, we look at solutions like Uber. If I want to go to anywhere with Uber now, I call for the service. So that platform is there for me to use, express myself, do whatever I want to do with it. I have to put, most of us may not have seen this Passat. I think this should be like Passat made in the 80s, but it's still what we use in Nigeria as taxis. They are yellow taxis. Yeah. Then we also have the solution, software as a service. That is a commercial bus, like you have YRT in York region. This is our own YRT in Lagos. So we hop into this and we hop out. just to show us the kind of lifestyle that is applicable in certain areas. Then we come into the benefits of cloud computing. First, it increases your speed and agility such that you can think of a solution today and in the next minute you may be selling it worldwide. You talk about elasticity, you can grow. Nothing is holding you. Before now, if you wanted to do certain solutions, you need to wait for 6 months for them to build the solution, ship it, customs clearance. A lot of capital is pumped in there, and you have to close the entire gap before you start thinking of making money. But in the cloud, you can increase, you can shrink, depending on the solution that you think about. Cost savings. All this leads to cost savings in the sense that you only pay for what you use. In the cloud, there are two separate solutions that you can consider. You could use serverless and server systems. Normally, the serverless is cheaper because even in the cloud itself, AWS, for instance, will be responsible for managing your serverless solutions, and your cost is further lowered. Then you talk about a situation whereby you start guessing about capacity. For instance, I'm going to run a telco business in Canada. I'll be thinking of Canada has 40 million people. I'm probably going to get 10 million people. Maybe in the first 1 year, I'll be looking at 2 million people. You start guessing, making some permutations and combinations to look at your capacity, and thereby pumping in a lot of financials that you would have used to do other businesses. Then you talk about massive economies of scale. Because the cloud solution is something that everybody they are already exposed to, and they have customers, over 1 million customers if my data is right. There is huge economics because normally you would have paid maybe $20 for a particular server, but because of the economies of scale, you could be paying as low as 10 cents for a particular service because there are a lot of people using this same scale with you. Then now you now talk about trading your capital expense for variable expense. How does this come in? Normally you would have gone to the banks, RBC, here I come, please give me $50 million, I want to run this project. But now you could still go to RBC and say, give me $2 million, I want to start this particular project, the same idea. However, you are no longer going to commit to get houses, to get structure, physical structure before you can think about your IT businesses. And the good news is that you can go global in minutes. Going global in minutes here is that you can decide to say, I want everybody worldwide to be able to maximize benefit from my solution. And at the same time, you could restrict and say, I want people from only certain regions or certain countries that I want to do business with. But the good news is you have the power to go global in minutes without having physical presence in any country. You could be in one local location and you still do everything you want to do. Then you talk about the issue of stop spending money on data centers. Here, for me to run a business with an on-premises infrastructure, I need to think about power, I need to think about security, I need to think about maintenance. There are some issues that could be popping up at any time. Then also think about redundancy. I will not say, I should have a geo-redundancy. So for instance, we're in Creation has an office in Toronto and has another office in Mississauga. You say, let me put some servers in Toronto office and put a redundant servers at Mississauga. So if there's a problem here, I will not switch my solutions to the other side. But in the cloud, you still have redundancy. You don't need to run or maintain data centers. So in terms of cloud infrastructure, there are global system nomenclature that is used. We have regions, we have availability zones, we have edge locations, regional edge locations. I don't want to go into details here because this will take a lot of our time. But this is just a nomenclature which all public cloud solutions they use in describing how you can access them. In terms of regions, you could have what we call availability zones. You hear people talk about AZ, AZ1A, AZ2, AZ3, whatever. For instance, in my account is hosted in North Virginia, and it is called US East 1 in AWS nomenclature, just to make a note. Now, inside the availability zone, this is where the cloud itself resides. What do you find there? you have servers, you have networking, you have storage, you have security, and load balancers. Sorry, there's a typo there. It's supposed to be load balancers. So all these are what make the cloud, and it is dedicated or situated in particular locations. For instance, this is a helicopter view of the availability zone at one of them actually at North Virginia. We talk about cloud computing deployment models. Companies, organizations today have grown to look at, okay, if I want to go to cloud, actually, do I just move everything from day one? No, it's not advisable. You need to transition. So we start from the default solution, which most organizations have, which is the on-premises. Everything is in your premises and you manage them. From there, we talk about a hybrid solution, whereby you put some things on premises and you put other things in the public cloud. For instance, most organizations want to keep their archive documents in the public cloud for starters and see protection and reliability from the cloud before they can move on and say, right, we've been satisfied, we've gotten 100% of what we wanted, and we can now go all out and put everything in the public cloud. So from there, we go to the common use cases of cloud computing. Normally, you have storage, you have test and development, serverless computing, AI as a service, high-performing applications, infrastructure, disaster recovery plan, building fault-tolerant systems, hybrid IT, security. These are just some of the minimum that I can think about. The list is actually richer than this. Maybe I'm a little bit economical here. So we have public cloud providers. Today, worldwide, we know that AWS is leading the pack. I also give them some respect here by putting a gap between them and Azure. Azure is chasing, and Google, for my friend Tom, who wants to be a developer, that's where you find Google. Then Alibaba is actually doing a great job. They are running and they are moving fast. They were before Oracle and IBM, but now Alibaba that's Jack Ma, a great guy. He's coming number 4 worldwide, and we know in no time he may be inching, if not above AWS. So I'll just put a little bit of a techie slide for you to see. This is actually a solutions architecture. We are looking about the DNS layer up until the storage and everything. So for instance, if I was to use a website name that you have, maybe something.ca, I can link you on through a CDM layer, which is the cloud front, to the static part of the site. This is mostly what happens in all websites. When you click on the website, you go to the static site first. What you see there are objects, photographs, and write-ups. We call them objects. But when you want to do a transaction, for instance, you want to check pricing, computing, maybe you are buying 10, 3, 4, 5 things, you are now redirected to the web layer, whereby you could have all kinds of combinations. These are load balancers. Tom, your API gateway, you can see where it comes in, and the elastic IP. And these are compute and all other kind of tools or layers that you can have when you are designing a solutions architect for an organization. So this is just a typical layout. It does not really talk about security here, because if I'm to add security drawings to this, you will not like this picture. It will look very unfriendly. So, ladies and gentlemen, I know we have some questions. So, sorry I was very fast, but I know there are some questions.